Hi, this video is about circles, graphing them, creating equations, and creating tangent lines. This is actually section 10.3. And before we get started, I just want to remind you about a few things that we learned back in 10.1 that you're going to need to know today. First of all, you're going to need to know the distance formula again. And if you want, you could even just pull out your notes from 10.1 to refer to as you're doing this video so that you don't have to write these down. But we have the distance formula, we have the point slope form of a line, and we're also going to use the slope formula today. Alright, so warm up, find the distance between 0, 0 and 4, 8. Here we go. We got 8 minus a 0 squared, 4 minus a 0 squared. So I end up with the square root of 80 for the warm-up. Okay, so circles. Standard form of a circle centered at 0, 0 is x squared plus y squared equals r squared. X squared plus y squared equals r squared, and r represents the radius. You're going to have something that's going to be added here and here when I have a circle that shifts and is not centered at 0, 0. So again, I want to say this is just for circles centered at 0, 0. So this example right here, the middle of the circle would be 0, 0, and the radius would be 3 because what the number I see right here is actually r squared. So if I square root that, I get 3. The first thing we're going to do today is graph these circles, and you won't see this too often in your book, but if they don't give it to you in standard form, go ahead and rewrite it so it is in standard form. So the first thing I get here is x squared plus y squared equals 25. And then here's what I want to do to create my circle. I am going to graph the center to start off with. So in this case, there's nothing with x and y, so I know that the center is at 0, 0. The next step is to find my radius and then create 4 dots that represent that radius. So if you're a real step-by-step person, maybe you want to say graph the center, graph the radius. And in order to draw a circle, it's best if we have at least 4 points. So this number right here is 25. Square root of that is 5. So in this situation, the radius equals 5. And here's the easiest way to do this. Just go 5 units in each direction from your center and draw a dot. So 1, 2, 3, 4, 5 in that way. 1, 2, 3, 4, 5 that way. 1, 2, 3, 4, 5 that way. 1, 2, 3, 4, 5 that way. And then connect your dots. It's okay if your circle doesn't look perfect. But there I have a circle centered at 0, 0 with a radius of 5. So let's try the next one. First, rearrange it. Then, again, because there is nothing with x and y, the center is at 0, 0. So here's my center here, and in this case, the radius is 2. So I'm going to go 2 units in each direction and draw my dot for my radius. And there it is. So center is at 0, 0, radius was 2 that time. Pause and have a look at that, write down questions if needed. Now we're going to do more with this. So let's suppose that I know a point 1, 4 is on a circle. It's centered at the origin. So I know that the center is 0, 0. I want to write the standard form of the equation of the circle. So here's what we're going to do. We are going to use this point to find what the radius is. And here is why it's not straightforward. If you make a graph of what's going on here, they gave me a point on this edge of the circle right here. So if I had known this point, I could have said, oh, radius is 4. But since this point is right here, I don't know exactly what the radius is. So I need to find the radius, and I'm going to do that by finding the distance between these 2 points. I know that that is on the edge of the circle, and from the center of the edge would be the radius. So I'm going to find the distance between those 2 points. Here's where the distance formula comes in. So I'm going to use the points 1, 4 that was given and 0, 0. And here I go. So x subtract x squared plus y subtract y squared. And I end up with 1 squared, which is 1, 4 squared, which is 16. So square root's a 17. And it's best to leave it in the square root form. The reason is, when I plug this into my formula, to get the number that goes right there, that is supposed to be r squared. So what I'll do is I will do r, which is square root of 17, squared, and so conveniently the square root and the square cancel each other. So the formula for this circle is x squared plus y squared equals 17. Okay, why don't you try B? So go ahead and pause the video and try B, and then when you unpause, I'll have the answer showing. So again, this circle is centered at the origin, so I'm trying to find the distance between -2, 5 and 0, 0. So see if you can plug that correctly into your distance formula, and try to do the equation of the circle too. See what you can do. All right, here's our answer. So the final equation is x squared plus y squared equals 29, and you should have gotten the square root of 29 for your r value. The next application, well actually let me just say first, so far today we have graphed circles centered at the origin is 0, 0. We have created an equation of a circle centered at the origin. Now I'm going to write an equation of a tangent line centered at the origin. And then when we go to the back side of this worksheet, we're going to do the same thing every time, except it's going to be circles not centered at 0, 0. Okay, but first you must know a tangent line means it comes very, very close to something and just touches it in one exact spot. So because we have a circle, our tangent line that I could create touches our circle at exactly 1 point. So while you're writing that, I'll draw up a little picture. So here's my circle, and it should touch it there. Okay, so that blue line is the tangent line. And what we're going to do is we're going to create an equation for that line. And now let me just say something. The way that I have this drawn right now, that tangent line is actually, well, it should be, okay? It's not, but it should be forming a right angle. If I drew a radius, so a radius from the center of the circle to the edge, because this is touching it right at the edge of the circle, it should be a right angle. So we're going to have something, our tangent line is perpendicular to a radius I could draw through the circle. Let me give you a step-by-step, and then we'll try a few, and you can see what I'm trying to explain here. Okay, so if I'm going to write an equation of that blue line, here's what I'm going to do. First, we're going to find the slope of, actually let's put it this way, find the slope from 0, 0 to the point we're given. And what I mean is, this is kind of like 10.1. I'm going to find the slope of this line, the radius line, because that's the line that I have enough information for. And then once I find the slope of that line, our slope is perpendicular to that line, so our slope is opposite reciprocal of that slope. So step 1, I'm going to find the slope from 0, 0 to the point on the line, and then step 2, I'm going to use the point that's given and the slope in my point slope form. This is very similar again to what we did in section 10.1. So here's an example. I know that I want to write the equation of the line tangent to the circle x squared plus y squared equals 20 at -2, 4. So let's just think about this for a second. First of all, the radius is the square root of 20, which is approximately 4.5. So I'm just going to draw a little picture. Drawing a picture is optional, but 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So in my rough sketch with a radius of approximately 4.5, there is my circle. At the point -2, 4 right there, I'm going to find the equation of this tangent line. And that's going to be perpendicular to the line I can draw, the radius, from that point to the center of the circle. So here's what we're going to do then. Step 1, we're going to find the slope of that blue line that I just showed you, and that blue line has 2 points. It has a point 0, 0 here and -2, 4. So I'm going to use these 2 points in my slope formula and find the slope. So the slope of that light blue line I just created is, on top, y subtract y, on bottom, x subtract x. So that slope is -2. So the blue line slope is -2. So think our slope is opposite reciprocal. So opposite makes it positive, reciprocal flips it to 1/2. So our slope is 1/2. And then if you remember to create an equation of a line, I need the slope and I need a point. We have a point because that's what was given to us. So I'm going to use my slope 1/2 and my point -2, 4 and plug it into the point slope form now. Alright, here I go. So y minus my y value, which is 4, equals my slope of 1/2 times x minus my x value of -2. Alright, first step, minus a negative turns it to a plus. Second step, let's distribute that 1/2. So it's really 1/2 x plus, and then just a second, 1/2 times 2 is 1. Half of 2 is 1. Last but not least, add your 4 to both sides. So my answer for the equation of that red line is 1/2 x plus 5. And if you look at my very informal sketch I just drew, that makes sense because, I mean, it looks like the line I drew has a y-intercept of approximately 5, and I just drew a quick sketch. So you could imagine if we tried to make a really nice picture, it probably would come out exactly to be that formula. I only have one example like that for it centered at 0, 0, so if you need to re-watch that, feel free. When you're ready, flip to the back. So now we're going to repeat everything that we just talked about, only we're going to do circles that have any other center but not at 0, 0. And so here's the formula for that, and specifically my center is going to be h, k, and r is still the radius. When I say h, k, I mean the opposite of what you see. And here, so it's better if I just give you an example. So if the circle is centered at -3, 5, the equation would be x plus 3 squared, y minus 5 squared. So I do the opposite of what I see. That's why those were negative kind of, and now they're positive for the center. So I do the opposite of what I'm given to plug it in, and then I do r squared. So radius 2 squared is 4. There's my equation of my line. Alright, let's draw this in. So the center is at -3, 5, 1, 2, 3, 1, 2, 3, 4, 5. And just like we did on the front page, first graph your center, second take your radius and draw, go 2 units out exactly in each direction to get your circle. And there it is. Okay, let's do it again. This time I'm not given such easy information. This time I'm given a center and a point. So let's graph that just to start off with, and then we'll find the specific radius. So my center is at -4, 8. 1, 2, 3, 4, 5, 6, 7, 8. And it has a point of -4, 6. Actually, they were really easy on us. Because they specifically gave us a point right here that is specifically 2 units away, I know that my radius is 2. Now, I don't know if I did that on purpose though, because I made this last year. So let me just really quickly show you. If, let's say I wasn't given a point that's so exact, I can find r mathematically by using that d formula again. So to find the radius, you can take the distance of those 2 points. So x subtract x, y subtract y squared. So I get 0 squared plus 2 squared, and that is the same thing that I kind of already figured out by just looking at the picture. Let's look at example C. Now I want to graph a circle with center at 3, 3 and point 6, 5. Okay, so this is a better example of what I was trying to illustrate. Because this time, if I graph my center, and then my point is at 6, 5, 6, 1, 2, 3, 4, 5. I could actually honestly draw in the rest of the dots just using logic, so let's just throw that out there. But I want to find the specific radius because it's very likely, hint, 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 that you're going to need to know the radius anyways for another problem you might have to do with the same circle. So here's what I will do again. To find the radius, I am finding the distance from the center to the edge. Remember, this represents the edge, that's the center, so I'll find the distance of that segment. And my distance is, again, my x subtract my x squared plus my y subtract my y squared. And 3 minus 6 is negative 3 squared is 9. 3 minus 5, 2 squared is 4. So my distance is the square roots of 13. And that doesn't really help me that much. So let's find what that is as a decimal. I know it's going to be less than 4. Okay, 3.6. So I'm going to do my best to approximately draw 3.6 in each direction. And again, if you're just straight up making a picture and you're only making a picture, honestly, just seeing that, oh, I went up 2 over 3, kind of using logic would be enough. Okay? And then the main reason why I really do need radius, though, is because it asks us to create the equation of the circle as well. So remember when I create this equation of a circle, did I do that for example B? Pause. I didn't. So we're going to have to go back and do that for example B. But when I create my equation of the circle, remember I put in here the opposite of what I have. So if it's a positive 3x, I put a negative 3 there. And if it's a positive y, I put a subtract 3y. And then I do my radius squared. Square root of 13 squared is 13. So that is the equation of my circle. So I could graph it using logic. I need to know the radius to create the equation. When you have that written down, let's go back and finish example B then, because I forgot to do that. So for example B, the center is at negative 4. So I put x plus 4, comma 8. So I'll put y minus 8. And then the radius is 2. 2 squared is 4. There's my equation for that one. Let's look at D. So this time I didn't have to write the equation, I just am asked to graph. So if I look at this, again, your x is the opposite of what you see, y is the opposite of what you see. So I know that my center is at 3, negative 5. And to find the radius, you do the square root of that number there, so my radius is 4. So 3, negative 5, 1, 2, 3, 4, 5. And radius is 4. We're going to go off our graph a little bit. Oh well. 1, 2, 3. I guess you could have made your xy coordinate plane in just a different spot to make it fit. Okay, there we go. And then one last thing, and I think this is actually kind of tricky, so if you need to re-watch this example, feel free. We're going to find the tangent line for a circle again, but this time I have a point that is not at 0, 0. So this time I have a point that is not at 0, 0. So here's what I'm going to do. Well, first let me just draw a picture so I can kind of visualize what's going on. Okay, so there's the center of the circle. 1, 2, 3, 4, 5, 1, 2, 5, 6, 7, 8. Okay, and then the tangency point is down here. So I have my circle, and then I'm drawing this line here is what I'm trying to find an equation for. And once again, I need to find the distance to find the, not the distance, take it back. I'm going to find the slope of this line because our blue line is opposite reciprocal slope because it's perpendicular. So step one, I'm going to find, basically I'm finding the slope of the radius, and I'm going between these 2 points they gave me. So y subtract y and x subtract x. I'm ending up with a positive 3 on top, and it looks like a 6 on bottom. Okay, so what I just found is that the slope of this red line is 1/2. So our slope that we're trying to find is opposite reciprocal. Opposite would make it negative, reciprocal would make it 2/1. So our slope is -2. And then right now we're going to have to create our equation, and let's see, how could I figure out which of these 2 points do I have to use actually to create my equation of the blue line? Okay, hopefully you said -4 comma -8. Unlike what we did in section 10.1 here, I specifically have to use this point right there because that's the only point I know that's on the blue line. In order to create an equation, I have to have a point on the line and the slope. So now I'm just going to take my y minus y1 equals blah, 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 blah. There I go. Oops. And I'm going to plug in my values. So here I go. So y minus a -8 equals -2 times x minus a -4. It's okay for us if you know those are going to turn to pluses. Let's do it. And then distribute, so I get -2x minus 8. Subtract 8, subtract 8. Okay, so the equation of that blue line is -2x minus 16. Again, just by eyeballing it, that seems correct. It looks like the slope, the y-intercept is going to go like way down here somewhere. That's it for 10.3 circles. Thanks for listening, and we'll see you again soon.